carbon black and silica for the resistance of the tyre to wear, whereby it's the silica as a high-grade material that ensures short stopping distances on wet roads. This is of particular importance for one component, i.e. the tread. Chemical additives such as antioxidants protect the tyre against premature aging. Natural and synthetic rubber form the basic material. During the mixing process, chalk, oils, resins, accelerating agents, retardants, compounding promoters, activators and sulfur are added. Start mixing, roll, cool, remix, roll again. Depending on the type of tyre or component, the operations and additives are varied until the required material properties have been obtained. The finished compound sheet can now be passed on for further processing. During the rolling out operation, the mixed compound sheet is shaped, cut and wound on a transport roller. The inner liner, a thin airtight rubber sheet, forms the first layer of the tyre. It takes over the function of the inner tube, once an essential extra. Two separate sheets make up the finished component, the inner liner. First, this is made flexible in a rolling mill. The calendar molds it into a compound strip. This is cut to shape for the tyre size concerned. The textile cord ply is coated in the calendar with rubber compound. Then the cord ply is cut so that when it is in place inside the tyre, the cord angle will be across the direction of travel, that is, in a radial direction. The textile fabric that is embedded in a rubber compound and forms the second layer adjacent to the sensitive inner liner acts as the reinforcing material. The radial positioning of the cord, that is, across the direction of travel, increases the strengthening properties of the ply. In this way, it is a crucial element in determining the load rating of the tyre, as well as such comfort features as its cushioning capability and its handling characteristics. Steel wire is covered with rubber compound, wound into a ring, and at the next station the extruded apex is applied. At the station bead and apex, steel wire and compounds form the rings that subsequently keep the tyre seated on the ring. The bead consists of several steel wires, each covered with a compound layer. Rolled up to form a ring, the bead will be joined with the apex at a later stage of production. The apex is manufactured at the same time on another manufacturing track. The apex sits on top of the bead. After the extruding operation, the apex is fed on rollers to the cut shape and then joined with the bead. Whilst the apex subsequently provides driving stability, steering performance and a high level of comfort, the bead ensures that the tyre is firmly seated on the rim. Steel wire is unwound from rollers, is covered by a compound in a calendar and is cut at an acute angle. The breaker is wound up for further processing. The steel heart of the breaker is located in the coil chamber. This is where the individual steel cords come together to form a fine steel cord ply. This ply is then coated with rubber compound in a calendar. The breaker, made of steel cords, ensures the rigidity of the tread in the longitudinal and lateral directions. This ensures power transmission during driving, improves the cornering stability, and increases the resistance to wear. After the extruding process, the tread is cut to the correct length and temporarily stored in transport units. Staying in contact. The tread is the element that keeps the tyre in contact with the road. The demands made on its properties are accordingly high. Up to 4 different compounds are processed at this station. Still marked with a colour code at this stage, this tyre layer will later be given its pattern. The tread is responsible for a good grip, durability and a low rolling resistance. The use of silica is an important factor in ensuring this. The actual contact area between the tyre and the road is no larger than a postcard, only a tiny area to carry so much responsibility. Carcass section. Bead and apex are joined with the inner liner and ply on the building drum. With the application of the sidewall, the carcass assembly is complete. Belt assembly section. Constituent parts are breakers, cap plies and the tread. Assembling section. Both assemblies are placed together and joined as one. The 2 tyre components, carcass and belt assembly, are united at the assembling station. Inner liner, ply, bead and apex, sidewall. And the carcass of the tyre is ready. The next item is the belt assembly. It is built up in several layers with breakers and cap plies that increase the strength in the belt assembly and are indispensable for high-speed tyres. Finally, the tread is put on. Belt assembly and carcass are pushed into each other in the last step, and after their wetting are joined together in the shaping station using compressed air. The final union takes place during the vulcanization process. The green tyre is put into a mould and then vulcanised at a temperature of over 170 degrees. It leaves the station as a patterned tyre. The proper term is vulcanisation. Some people call it baking. Whatever you say, it is the last manufacturing stage in making a tyre. The green tyre is given its tread and is cross-linked. The components are now inextricably joined together. After the baking mould is closed, a bladder is inflated inside the green tyre and presses it into the mould. Baking time, approximately 10 minutes. Temperature, between 170 and 200 degrees Celsius. Pressure, up to 22 bar. These values depend on the type of tyre and its size. The compounds are transformed into elastic rubber. The green tyre becomes the finished tyre. The visual and sensory checks are the last stages of the manufacturing process.